Hello. I'm just gonna give a brief of walkthrough of Edge Impulse. Basically, Edge Impulse is like a user-friendly way to create, AI models that classify images, audio classifications, and whatnot. This is a brief walkthrough. Basically, first I want to create a model that distinguishes between a car and a truck. So what I'm gonna do, I'm gonna give it an image, and it has to distinguish between whether it has to classify whether it's a car or a truck. So first of all, what I'm gonna do is I'm gonna provide it training data. So the data set, I'm just going to build a data set of cars and trucks so that it knows to learn the difference between a car and truck. So first we're going to feed the data. So I'm just going to click on add data. I'm going to upload the data. So here there's this button. So I'm going to select a folder. I have a folder full of car images. So I'm going to select that. So this is the folder. I selected that, and now it will automatically upload all the files in that folder, and I want it to automatically split between the training and the testing. So basically I'm going to sample between my training images and testing images. I'm going to give it a label as car because I know that these are car images. I've collected the data, so now it's uploading, and once it's uploaded you can see that it's populated with images of cars that I have that was present in that folder, and it has automatically split between training and testing. Now I have to upload truck images, so I'm just gonna upload that as well. Click here, select the folder, choose the folder. So this is the truck folder. I'm gonna select that, upload it, automatically split, and enter the label as truck. So I've uploaded that, and so now both the images of both the data sets for the cars as well as the trucks have been uploaded, and total of 27 items were there, and the test to split ratio is 81% and 19%, meaning out of the images that I've uploaded, 81% is for training the model and 19% is for testing the model whether it is getting the answers right or wrong. So my data set is ready. I've collected all the data, so now I can move forward on creating the model. So here's the impulse is basically the flow that we have over here. So I'm just going to delete this. I want to create it again. So basically this is your input data image. Okay, so it is we can specify its height. For now it's 196 into 96. If I wanted a little more clarity and resolution, I can add 128 into 128. Basically what it's going to do is it's going to take that image and crop it to this size that we have mentioned, and if there's any fit issues, it's going to fit along whichever axis that we mentioned. There's different options over there you can explore. So we're gonna add a pre-processing block. Basically this is a block to convert or filter certain parameters of the data. This that we see over here is a raw image, so we must be able to convert it to say for example we want it to grayscale. We don't want color, we want it to be grayscale, or we want certain features highlighted, so we can add the pre-processing block. I'm just gonna there's certain options which we can choose from. There's this raw data option which it passes the raw data as is, does any modifications, and we also have certain other filters over here. I'm just gonna you know add the recommended filter. This pre-processes the image and normalizes the data, reduces color, which we don't need for much feature or differentiation. So I'm gonna add that. So this is the pre-processing block. Okay, and once that is added, now I can feed it to my brain, that is my classification model. So that is a brain. So I'm going to add a learning block. So this learning block is for images. So I'm just going to add this learning block over here, transfer learning, fine-tune pre-trained image. So basically this model is not, it's pre-trained on some large data set, okay, of images. So it's not, this is not the first time that this model is training. It has already been trained. The only thing that it's doing now is it's going to fit, and it's going to adapt to my data sets. Okay, so I'm just gonna add this transfer learning image model, and now it has the input features of this image as well as car and truck as output features. Basically my output, I want to distinguish between a car or truck, so I've added this block over here. So this is my brain, okay, and this is the output features, this layer. So this is the flow, okay. Image comes like this, goes through this filter, the model judges whether it's a car or truck, and the output is sure. So I'm just gonna save this impulse. Okay, so that's saved. Now I'm just going to go into the images thing. So basically this is for feature extraction. This process is called feature extraction. What happens here is that it looks at your image and it tries to form certain features. So basically, is there an edge over here? Okay, what shape is this, what shape is that? And in the image it tries to maximize and grasp the features of that image. So it converts it into DSP, I think digital signal processing, some output, and it converts it into mathematical tensors or arrays of values. So I'm just going to generate that feature. So this is like a pre-processing step before training the model. We're just going to generate the feature so that it has better analysis capability, so the model is able to better analyze. So I'm just going to go ahead. This might take some time, so I'll just pause it over here. So now that that process is completed, all the features have been extracted. So it'll take some time to calculate the feature explorer, but I think the features are mostly extracted. So now we can go over here, and as we can see, it's the same page. So now we can go ahead with the transfer learning. So this is your base, this is your training, okay. So this is how you adapt your data set to the model, okay. So this model probably has been trained with millions of images, but we need to adapt it to our requirements. So number of training cycles just indicates that how many time do you want to run the cycle of propagating and also back propagating the neural network to learn, adapt its weights, and adjust its biases. So I'm just gonna set sufficient number. I don't want to go too high and overtrain my thing, and use learn optimizer. It's just going to use whichever optimizer it was used to train this neural network. That same optimizer will be used here, but I don't read that. I just want a standard one. Learning rate is how fast it learns. You don't want to set this value too high, because if you set this value too high, what happens is that it learns, and at a certain time it reaches a good accuracy, but then because of the speed and because of the momentum, it it becomes inaccurate after some time, after some epochs. Processor is CPU, data augmentation not required. It's just a simple data set, so not required. Augmentation basically just it increases your data set. It does some sort of random rotation, random filtering, random skews, and it just increases your data set. Here we have our input layer, that is for 49 152 features. Basically this is your input, your image is getting pixelated, and all those 49 152 pixels are inputted to that layer. So this is the input layer of a neural network, and this is a neural network. It's a MobileNet v2. It's like a simple, lightweight, optimized neural network designed by Google, and it's basically used best for edge devices, like the devices that have low computation capability but need AI. So it's for that. So we have 16 neurons in the final layer, which converges into two classes in the output layer, which is basically a car or truck. So I think our feature extraction is almost done over here. Yeah, so I think that's done. So now I think we'll begin by I think we'll have to do process one more to generate the features. Once that's done, we'll quickly go ahead to training. So the feature extraction has been completed. It was before, just confirmation. Now I can just train. So I'll just set this to 10. Rest I'll leave it as is. Input layer, everything looks good to me, and all I have to do is save and train. So this again will take some time. It's going to train, and it'll improve the accuracy, and it has to verify, it has to test. So it's gonna take some time, so I'm just gonna pause. So as we can see, the training process is completed. We have an accuracy of 100, which is good, and a loss of 0.22. This is our matrix, confusion matrix over here. The training is successfully completed. Now we can go ahead and test some live classifications. So I'm just gonna give it an image of a car, a random sample set of a car, and okay, let's see what the predictions are. It's it's showing it has a 81% surety that it is a car, and a 19% sure that it is a it's a 19% sure that it is a truck. Obviously, the high percent wins, so it is sure that it is a car. So there you go, car. So it has correctly classified from the things that, and we don't want this. We want to classify our own image, right? So what we'll do is that there's this model testing features as well. You can just classify all, and it's taking the time to classify. Again, this will take a little time, so I'm just gonna pause it here as well. Now that it's done classifying it, I mean, it's pretty good. I mean, it got one image wrong. It expected a truck, but it got, the result came a car. But that's fine. We have an 80% accuracy. This can be avoided if we have more data sets and, distinguish things. But for considering that we have like only 27 images in our data set, this is, pretty good. So there's a confusion matrix. It classified one truck incorrectly as a car, so that's fine. We'll improve the accuracy. So I suppose I want to run this model. Now it's in this app. Like, I don't know how to run it. Say I have a Raspberry Pi 5, or I have an Arduino Q. How do I run it there? So it also has deployment features. So basically, there's a variety of deployment features. I can convert it into a C++ library, Android library, Arduino library, and whatnot. I have a lot of deployment options. So Arduino, certain chips. So there's a lot of deployment option, but I'm gonna choose the Docker one because I find Docker a very good abstraction, and we don't have to worry about a lot of complications under the hood. So what all I have to do is just copy this docker run command. Basically, this command is used to start a Docker container at the port 1337, and this is the repository where the container is located. This is the API key for security, and I'm just gonna run. It's just gonna run the HTTP server. So as you can see now, I'll convert. I'll just extract this model from the cloud, that is this Edge Impulse, to my local machine, that is the laptop that I'm currently running this on. So I'm just going to do that. Just for filtering out all the things, I'm just gonna paste it into Notepad and remove the unnecessary slashes from this command, because that will give me an error. And yeah, so I'm just gonna remove that, and I don't need that, and just yeah. So now I have a clear command, so I'm just gonna copy this command. I'm going to go into command prompt. Okay, this is DOS, Microsoft DOS. So I'm just gonna paste this command, and I'm gonna enter. So what's this doing is that it's going to build that, it's gonna pull that Docker image from the cloud, and it's going to run it. So I just want optimized. I don't want. I just want to run the model. So it's in the current stage of building the Docker, and starting up the application. So it's gonna take some time. So I'm gonna pause. So once that build process is done, we have our server running at the local host. Basically, this is irrelevant. It's in the container's IP. I don't want that. I want it in my machine. So it's running at 1337. So it's running at localhost 1337. So I'm just gonna open a browser tab. I'm gonna type localhost 1337. Okay. And there you go. This is my Edge Impulse interface. Now you may ask how this is this like a web application. How you're gonna interact it with your Raspberry Pi, or say I have a Python code. How you're gonna interact with it? So basically, this is just a web viewer of this model. So I can choose a file. Say I randomly chose a truck file. Okay, I randomly chose that image, and I'm gonna run. Okay, I'm gonna ask it, can you classify this? And it says that okay, I'm 98% sure that this is a truck, and I'm only 1% sure that it is a car. So hey, it classified it correctly into a truck. So how might you interact with this in like a Python environment, Python language, or some other language? So basically it has also API interfaces. That's basically, this code is just you know a command that is used to call APIs. So I'm just going to, so in order to test this API that I can run using call command, I can also use another um, API tester. So basically I have this talent API tester which I can use to test my API. So I'm just going to run a post request to this particular path over here. So this one URL, I'm just going to paste it, and I'm going to run a post request. So its content type is different. Actually it's different form data, so I'll remove this. It's basically a form. So I want to add the body in a form format, so I'll just quickly change that to file. Okay, now I'm gonna choose a file, so I'm just gonna choose this truck file. Okay, so image jpg, so the truck file is chosen, and now I'll just send this file. Okay, so I'll just send the request and saying bad request, no file posted, request requiring a multi-part form data with one item file. Form probably file. Okay, and I just need a file. So yeah, so I think I fixed that error. So yeah, so it is classifying it as a truck correctly, and I am able to access this API. Now all I have to do is write code to access this API in any programming language I want, and I can automatically and seamlessly integrate AI into my applications. Thank you.